Okay, today we are converting degrees to radians and radians to degree. These first two vocabulary terms, we covered these yesterday. We found that a radian is just a unit of measure where we use the radius. And standard position is best seen visually, so a visual definition. An angle is in standard position if its vertex is at the origin, its initial side is on the positive x-axis, and the second side is called the terminal side. And with that, we're using positive rotation. So I'm going to call this angle, angle A. Now, the new definition for today, coterminal angles. It says a pair of angles are coterminal if their terminal side of theta in the same spot. So looking at angle A, that's if I use positive rotation. So if I use negative rotation, I would go clockwise. So here's still my initial side. This angle is also in standard position. So the vertex is at the origin. The initial side is the positive x-axis. So now I'm using negative rotation. I'm going to call this angle, angle B. Now, angle A and angle B are said to be coterminal because they terminate on the same ray. So if they share a terminal side, they are coterminal angles. Now, let me give you a visual with actual values. So here's my xy coordinate plane. My angle is going to be in standard position. So the initial side is on the positive x-axis. And I'm going to try to do my best to make this a 45-degree angle. Now, I want to find what is the negative angle that is coterminal to positive 45 degrees. So this rotation was positive. But if I rotated negative, if I did negative rotation, I want to figure out what would that angle be. So we're still starting at 0 degrees, but now we're going clockwise. So if I'm going clockwise, instead of being positive 90 degrees, this is negative 90 degrees. So if you're going clockwise, it's negative. So this is negative 90 degrees. This becomes negative 180 degrees. This becomes negative 270 degrees. And 0 degrees would also be negative 360 degrees. So if I'm trying to figure out what is this entire angle, well, I stopped writing my measures here at negative 270 before I got to my angle. And what part would be right here between 270 and the terminal side? How many degrees would this be? 45. So 270 plus 45, what would that angle be for the negative rotation? Negative 315 degrees. So I'm going to write down here that negative 315 degrees and positive 45 degrees are coterminal. And they are coterminal because they terminate on the same ray. So negative 315 degrees and positive 45 degrees are coterminal. They terminate on the same ray. Now, for the first set of problems, we're going to be finding coterminal angles. I don't have to draw a diagram each time, so we'll find ourselves a shortcut here in a moment. So the instructions say, given a positive angle, find a negative angle with the same terminal side. So that's part one. Part two, you have to state which quadrant each angle terminates. So looking back at my pair of angles, we had negative 315 degrees and positive 45 degrees. So for the first section, they are going to give us the positive angle. And I want to determine what do I do to my positive angle to get the negative angles that coterminate. What could I do to 45 degrees to get negative 315 degrees? Yeah, subtract 360 degrees. So if you are given the positive angle, to find the negative coterminal angle, subtract 360 So that's what we're doing in the first section. So if you are given the positive angle, subtract 360 degrees to find the negative coterminal angle. And what is 315 degrees minus 360 degrees?
Negative 45.
So that first part is negative 45 degrees. So that's part one. We need two answers here. We need the negative angle, and then we need to state which quadrant would that angle terminate in. So let me sketch coordinates line over here. And we're using negative rotation. Let me label the quadrants first. Here's quadrant 1, quadrant 2, quadrant 3, and quadrant 4. 0 degrees. And if we have negative, that means we are rotating from the positive x-axis. We are rotating clockwise. So negative 45 degrees would terminate in which quadrant? 4. So that's part 2. So part 1 states the negative coterminal angle. Part 2 states which quadrant it would terminate in. Next one, number 2, 230 degrees. To find the negative coterminal angle, subtract 360 degrees. And what's 230 degrees minus 360 degrees?
130.
Negative 130 degrees. So there's the first answer. Now for negative 130 degrees, we have to determine where would that angle terminate. So this is 0 degrees, this was negative 45, so this would be negative 90 degrees. Over here would be negative 180 degrees. So negative 130 degrees would terminate in which quadrant?
3.
Quadrant. We're going negative, it would be 3. And number 3, to find the negative coterminal angle, just subtract 360 degrees. So what is 100 degrees minus 360 degrees?
Negative 260.
Negative 260 degrees. So there's the first answer. Now we have to determine in which quadrant would that terminate. So this is negative 90, negative 180. This would be negative 270 degrees. So in which quadrant would negative 260 degrees terminate?
2.
This time it's in quadrant 2. And number 4, to find the negative coterminal angle, we need to subtract 360 degrees. What happens when you subtract 360 degrees? Do you get a negative answer?
240.
You get positive what?
140.
140 degrees. So my answer has to be what? Negative. So if it doesn't work the first time, do it again. So keep subtracting 360 degrees until you get to the first negative angle. And what's 140 degrees minus 360 degrees?
Negative 220.
Negative 220 degrees. And negative 220 degrees would terminate in which quadrant?
2.
Quadrant 2. Okay, next row of problems. We are still trying to find that negative coterminal angle. But this time, they don't give us degrees. What are they giving us?
Radians.
Radians. So instead of subtracting 360 degrees, how many radians is 360 degrees?
2.
2 pi. So we need to subtract 2 pi. In order to do that, we'll have to have common denominators. Common denominator would be 4, so this would be pi over 4. And what would this have to be in the top?
Negative 8 pi.
Yeah, 8 pi over 4. And what's 1 pi over 4 minus 8 pi over 4?
Negative 7.
Negative 7 pi over 4. Now we'll have to determine in which quadrant would that one terminate. So let me draw the coordinate plane. This is quadrant 1, quadrant 2, quadrant 3, quadrant 4. If you're counting by pi over 4, that would be 45 degrees. So using negative rotation, down here would be negative pi over 4, negative 2 pi over 4, which would be negative pi over 2. This would be negative 3 pi over 4. Negative 4 pi over 4 would be negative pi. negative 5 pi over 4, negative 6 pi over 4 would be negative 3 pi over 2. So negative 7 pi over 4 would terminate in quadrant 1. So this was negative 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, and negative 7 pi over 4 would be right here in the middle of quadrant 1. And number 6, to find the negative coterminal angle, subtract 2 pi. So I have to have a common denominator, which would be 6, so this would be 7 pi over 6, and this would be 12 pi over 6. And what's 7 pi over 6 minus 12 pi over 6? Negative 5 pi over 6. So now let me get this marked with increments of pi over 6. So instead of negative pi over 6, this is also equal to negative 3 pi over 6. Negative pi is also equal to negative 6 pi over 6. And negative 3 pi over 2 is also equal to negative 9 pi over 6. So negative 5 pi over 6 would terminate in which quadrant? Quadrant 3 is correct. And number 7, subtract 2 pi. So this would be 25 pi over 3. Minus, instead of 2 pi, that would be
6.
6 pi over 3. Does that give me a negative? No. 25 minus 6 would give us 19 pi over 3. If I do 6 again, would that work? What about if I double it? What if I did 12? Would that work? If I did 3, not 12, 18. So I would have to actually subtract what?
24.
24 pi over 3. Or you could just keep doing 6 pi over 3, 6 pi over 3. Or you could just do it 4 times, which is 27. Okay, and if we subtract, what's 19 pi over 3 minus 24 pi over 3? Negative 5 pi over 3. So negative 5 pi over 3. Since I already have this one marked up with pi over 6, there's my answer here. But what if I made this with a 6 for the denominator? This would be negative 10 pi over 6. And in which quadrant would negative 10 pi over 6 terminate?
On the line.
Quadrant 1. If this is negative 9 pi over 6 and negative 10 pi over 6, it would be somewhere over here in quadrant 1.
Do you have to do the quadrants denominator?
Yes, quadrants are always Roman numerals. Next section. Now it says given a negative angle, find a positive angle with the same terminal side and say which quadrant each angle terminates. So now we're doing the opposite. Now we are given the negative angle and we have to come up with the positive angle. So what would I have to do to negative 315 degrees to get 45 for the answer?
Add 360.
Add 360. So add 360 degrees, and what do we get? Positive 180 degrees. That's part 1. Now I have to state which quadrant would that terminate in. And now we're using positive rotation, so going counterclockwise.
What's on the line?
180 degrees is where? On the x-axis. So if it falls on an axis, if it does not land in a quadrant, state which axis it would fall on. So 180 degrees does not fall in a quadrant, it is on the x-axis. So just state x-axis instead of a quadrant. Number 9, to find the positive angle, add 360 degrees. And what's negative 805 degrees plus 360?
Negative 445.
Negative 445.
Yes.
Add another 360 degrees. Because we need a positive, so if you don't get a positive, keep adding 360 until you get to a positive angle. And when you add 360 to that, what do you get?
Negative 85.
Negative 85 degrees. Have to do it one more time. What's negative 85 degrees plus 360 degrees?
275.
275?
Yes.
So 275 degrees. And 275 degrees terminates in quadrant 4. Next one, instead of adding 360 degrees, what would that be in radians? 2 pi, so add 2 pi. So we'll need a common denominator, so this would be negative pi over 4. This would be 8 pi over 4. And when you add those, what do you get? 7 pi over 4. And if you're counting by increments of pi over 4, that's 45 degrees. So using positive rotation, this would be positive pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4. So 7 pi over 4 terminates in which quadrant? 4. And number 11, add 2 pi to get to the positive radian measure. So this would be negative 35 pi over 6 plus 12 pi over 6. Is that going to get me close to being positive?
No.
Try 24. Would 24 over 6 work?
No.
No. So the next one would be what? 36 over 6. So let's just go ahead and do 36 pi over 6. And that's just so we have to only do it one time. And if we add those together, what do we get? Pi over 6. And pi over 6 terminates in which quadrant? Quadrant 1 is correct. Next section. Next section says, it says convert degrees to radians, and it says your answer needs to be in terms of pi. So that means leave the pi symbol in your answer. And the way that we convert degrees to radians is you need to multiply by pi over 180 degrees. And that's something you'll need to memorize. To go from degrees to radians, you need to multiply by pi over 180 degrees. So if I do that, multiply 200 degrees by pi over 180 degrees. Now the reason why the degree has to be in the denominator is that way the degree symbol in the numerator will cancel with that degree symbol in the denominator. And now, if I make this into a fraction, if I multiply the numerators, that would be 200 pi over 1 times 180 is 180. Now, it says to leave your answer in terms of pi. So that means I need to keep the pi symbol in my answer. But make sure you simplify your fraction. So 200 over 180, those zeros, I don't need them. And 20 over 18, that simplifies to what?
10 pi over 9.
10 pi over 9. So 10 pi over 9. Final answer. Next one, number 13. To go from degrees to radians, you need to multiply by pi over 180 degrees. And the degree symbol in the numerator will cancel with the degree symbol in the denominator. And when we multiply that, that gives us 120 pi over 180. Simplify that fraction, and 120 over 180 simplifies to
2 pi over 3.
2 pi over 3. Final answer. 14 and 15 are done the exact same way, they just threw in a negative for us. So we're still going to multiply by pi over 180 degrees. And we want that degree symbol in the denominator. That way the degree symbol in the numerator will cancel with the degree symbol in the denominator. So that leaves us with negative 225 pi over 180. So our answer will be negative. We'll have that pi symbol. And we need to simplify that fraction. So what does that fraction simplify to? Yeah, 5/4. So negative 5 pi over 4. And number 15, multiply by pi over 180 degrees. And the degree has to be in the denominator. That way the degree symbol in the numerator will cancel with the degree symbol in the denominator. And that gives us negative 90 pi over 180. And that simplifies to?
Negative pi over 2.
Negative pi over 2. Next section, we're still converting from degrees to radians. So we still need to do the same thing. We still need to multiply by pi over 180 degrees. But this time, they don't want our answer in terms of pi. They want us to do what with the answer? Round to 3 decimal places. Do not use 3.14 for pi. Make sure you use the pi symbol in your calculator. And I'll show you on the Inspire and on the 84. So the same method, so now we need to type it in. So the degree symbol in the numerator will cancel with the degree symbol in the denominator. And that gives us 300 pi over 180. Calculator time. So if you're using the Inspire, you can do Control divide for the fraction, 300, and for the pi symbol, if you need to hit this button over here, that's to the left of the keypad, or not the keypad, but the alphabetic keypad down there at the bottom, and the pi symbol is that first one. And then we need 180 in the bottom. And to 3 decimal places, that would be 5.236. So 5.236. And I'll switch over to the Elmo in just a moment so you can see what it would look like in the 83 or 84. So if you're using an 83 or 84, you'll need to do the second, and then you'll have to use that caret key. That's just that up arrow. And this caret symbol, this caret button, or caret key, is right above the division symbol. So let me show you on an 84. 83 works the same way. Okay, so type in the 300, and then the pi symbol, you do second caret key, and that's the button right here above the divide key. So there's the caret key. And then you need to divide that by 180. And to 3 decimal places, we got the same exact answer, 5.236. So you can use an Inspire, use an 83, use an 84. You'll get the same answer. Next one. Again, going from degrees to radians, we need to multiply by pi over 180 degrees. Pi symbol in the numerator cancels with the pi symbol in the denominator. And that gives us 85 pi over 180. And to 3 decimal places, it's 1.484. I want you to do 18 and 19, multiply these by pi over 180 degrees, multiply by pi over 180 degrees, and we'll check your answers here in a second. let's see, these degree symbols cancel, so this is 150 pi over 180. And what did you get for that one?
2.618.
2.618. Next one, the degree symbol in the numerator and denominator cancel. This is negative 135.8 pi. Divide by 180. And to 3 decimal places, what was this one? Negative 2.370. Next section. Now we are doing the opposite. Now we are converting from radians to degrees. So if you're going from radians to degrees, you need to cancel the pi symbol. So this time pi needs to be in the denominator. 180 degrees needs to be in the numerator. So if you're converting from radians to degrees, you need to multiply by 180 degrees over pi. Okay, when we do that, the pi symbol in the numerator will cancel with the pi symbol in the denominator, and that's 180 degrees divided by 4. The calculator, you don't have to have the degree symbol. Just do 180 divided by 4, and how many degrees would that be? 45 degrees. Make sure you have the degree symbol in your answer, though. So if they're asking for degrees, you need to have that degree symbol in your answer. 21, to go from radians to degrees, the pi symbol needs to be in the denominator so that those will cancel. 180 degrees goes in the numerator. Pi on top, pi on bottom. And this ends up being 180 degrees divided by 2. And what's half of 180 degrees? 90 degrees. Go ahead and do 22 and 23. Multiply by 180 degrees over pi. Multiply by 180 degrees over pi. Pi on top, pi on bottom will cancel. You have a negative 180 degrees over 3, and that is what? Negative 60 degrees. Next one, pi in the numerator, pi in the denominator, those cancel. We'll have to do 3 times 180 degrees over 4. And what is that one? 135 degrees. I agree, 135 degrees. Next section, we're still doing the same thing. We're still going from radians to degrees, but now they want us to round to the nearest 10. So that means we'll have to put these in the calculator. So if you're going from radians to degrees, you still need to multiply by 180 degrees over pi. But this is all calculator work. So we need to multiply 3.41 by 180 degrees. Don't use the degree symbol in the calculator. And then divide by pi. So in the calculator, it's 3.41 times 180 degrees. Don't use the degree symbol. And make sure you use the pi button. Don't use 3.14, use the pi symbol so your answer is more accurate. And rounding back to the nearest tenth, it would be 195.4. And this needs to be in degrees, so don't forget the degree symbol. So 195.4 degrees. 25, we still need to multiply by 180 degrees over pi in order to convert from radians to degrees. So this would be negative 125.3 times 180 degrees divided by pi. Now this one, it looks big, but it's actually a really, really small number because we got negative. And again, make sure you use the pi button. Don't use 3.14. And rounding that very, very small number to the nearest tenth, so it would be negative 7,179.2 degrees. And don't forget that degree symbol. Go ahead and do 26 and 27. Multiply both of these by 180 degrees over pi to convert from radians to degrees. What did you get for 26? 322.0 degrees. So that one's the nearest tenth, that was 0. And for 27, what did you get? 3,250. Okay. There we go. 51.5. 0.5 degrees. Pen doesn't want to work for some reason. Okay, 4 more problems to go. This next one, it says if the terminal side of theta in standard position passes through point P, draw theta, and find the exact value of the 6 trig functions of theta. So if it asks you for the 6 trig functions, it's talking about sine, cosine, tangent, cosecant, secant, and cotangent. So those are the 6 values we need. And remember, when you're trying to remember the reciprocals, S and C are paired together. So the reciprocal for sine is cosecant. And what is the reciprocal for cosine? Secant. And what is the reciprocal for tangent? Cotangent. So we need to find all 6 of those answers. Sine, cosine, tangent, cosecant, secant, and tangent. First thing we need to do, draw ourselves a little diagram. And we need to plot the point 6,8 on our xy coordinate plane. So the x-axis needs to go up to 6, the y-axis needs to go up to 8. So 6,8, there is my point P. Now they did tell us that this angle is in standard position, which means the vertex of this angle is at the origin, the initial side is on the positive x-axis, and they said that the point P is on the terminal side. So the terminal side of this angle theta needs to go through the point P. And theta, if it's in standard position, we're using positive rotation. So we are rotating upward. So here's my angle theta. Now, in order to find sine, cosine, and tangent, to use SOHCAHTOA, what do you have to have?
Side.
We have to have sides, but we have to have sides of a what? What type of triangle?
Right.
A right triangle. So what we have to do is we have to form a right triangle. So when you are forming your right triangles on these coordinate planes, you always draw the vertical line from the terminal side. So here is my terminal side. And you drop from the terminal side to the x-axis. So how do you make your triangle? You go from the terminal side to the x-axis. And there's my right triangle. Now I can label my sides. The bottom or the base of this triangle is how many units?
6.
6. The height is how many units?
Gotcha.
8. And to find that missing hypotenuse, we could use the Pythagorean theorem, or hopefully you recognize that this is a 3, 4, 5 Pythagorean triple. But it's been doubled. It is now 6, 8, 10. So that hypotenuse is 10. Now that we have all three sides, we can find those 6 answers. So using SOHCAHTOA to find sine, we need to do opposite over hypotenuse. So here's my angle theta. What side is opposite of theta?
8.
8. And what's the hypotenuse?
10.
10. Make sure your answer is in simplest terms. So 8/10 simplifies to
4/5.
4/5. If the sine is 4/5, what is the cosecant?
5/4.
5/4. Cosine, using SOHCAHTOA, how do you find cosine?
Adjacent over hypotenuse.
Adjacent over hypotenuse. So looking at theta, what side is adjacent to theta?
6.
6. The hypotenuse is still 10. 6 over 10 simplifies to 3/5. So if the cosine is 3/5, what is the secant? 5/3. For the tangent, using SOHCAHTOA, how do you find tangent?
Opposite over adjacent.
Yes, opposite over adjacent. So the opposite side of theta is 8. The adjacent is 6. And 8 over 6 simplifies to
4/3.
4 over 3. And if the tangent is 4/3, the cotangent would be
3/4.
3/4. Next one. Draw another coordinate plane. This time the x-axis needs to go to -4. Y-axis goes up to 2. Here's my point P at -4, 2. Now again, they said that our angle's in standard position, which means the vertex is at the origin, the initial side is on the positive x-axis, and the terminal side goes through -4, 2. So this angle is theta. Notice theta is obtuse. So when we're solving these triangles, we need to have an acute angle. We can't have an obtuse if it's a right triangle. The other angles cannot be obtuse. They have to be acute. So when you are making your right triangle, you have to draw your vertical side going from your terminal side to the x-axis. So terminal side to the x-axis to make your right triangle. So if this is the right triangle that I'm using, we need to be looking at this angle that's between the terminal side and the x-axis. And if we already use theta over here, I'm going to call this theta with a subscript of r, and that stands for a reference angle. So this is our reference angle to find those trig values for theta. So we're going to be using this theta reference angle to solve it. Now, we're about to go against everything you've been taught about side measures. You've always been taught that sides cannot be what? Negative. But if I'm looking at the base of this triangle, I'm going from 0 to -4. So the length is actually -4 according to that coordinate plane.
Stop changing math.
I know, stop changing math, right? So with these trig values, we will have negative side length. So you do have to be careful. So if you're on the left side of 0, it's negative.
Why?
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 Well, you gotta make it more
More complicated. It's not
Because we have to get the correct value, sine, cosine, it has to be positive or negative, we have to have the correct sign in place. And if we don't put that negative, we won't have the correct sign. Okay, for the height of the triangle, if it's above 0, it's going to be positive, and it goes up to 2. Now, the thing about the hypotenuse is always positive. So you don't have to worry about if the hypotenuse positive or negative, it's always positive. So now, 2 and 4 is not Pythagorean triple. So to find that missing side, we will have to use Pythagorean theorem. So a squared plus b squared equals c squared. So this will be 2 squared plus negative 4 squared equals c squared. 2 squared is 4. Negative 4 squared is 16. 4 plus 16 is 20. To get rid of the square root it. Now, if your radical can be simplified, make sure you simplify. So instead of leaving it at square root of 20, what would that be? Instead of 4 square root of 5, it should be, 2 square root of 5. So take the square root of 4 to get to 2. So the hypotenuse is 2 square root of 5. Once you have all three sides, you're ready to find the sine, cosine, tangent, as well as the other three. So I need sine of theta. We need cosine of theta. We need tangent of theta. And what's the reciprocal for sine? Cosecant. So we need the cosecant of theta. And the reciprocal for cosine is secant of theta. And the reciprocal for tangent would be cotangent. So using SOHCAHTOA, how do we find sine?
2 square root of 5.
Opposite over hypotenuse, I agree, that would be 2 over 2 square root of 5. And those 2's cancel. And what's left in the top? A 1 over square root of 5. Now that's not right, that's not the right answer because we need to rationalize that. So before we rationalize, let's go ahead and find the cosecant. And if the sine right now is 1 over square root of 5, what would the cosecant be? Square root of 5 over 1, which is the square root of 5. Now let's finish rationalizing this. So we need to multiply both the numerator and denominator by square root of 5. So that answer would be square root of 5 over 5 for the sine. Cosine, how do you find cosine using SOHCAHTOA? Adjacent over hypotenuse. So the adjacent side is -4. The hypotenuse is still 2 square root of 5. What's -4 divided by 2? 2. Yeah, so that's -2 over square root of 5. Now that does need to be rationalized, but before I rationalize it, what would the secant be?
-5 square root of 5 over 2.
Yeah, the square root of 5 over -2. Now finish rationalizing, so multiply both numerator and denominator by the square root of 5. That gives us -2 square root of 5 over 5. And the tangent will be better, and using SOHCAHTOA, how do you find tangent? Opposite over adjacent. So the opposite side is 2. The adjacent side is -4. And 2 over -4? -1/2. And what would that cotangent be? -2. Next problem. Now they're going to change it up on us. Now they don't give us a point C, but they tell us to find the exact values of the other 5 trig functions. So they're giving us one of the trig functions. We have to find the other 5. They tell us that theta is in standard position. So we need to start with a diagram. And they say that theta is between 270 degrees and 360 degrees. So which angle would theta be? Yeah, it would be obtuse. If it's in standard position, its vertex is at the origin, initial side is on the positive x-axis. But if it's rotating, let's see, this would be 90 degrees. This would be what? 180 degrees. This would be, down here would be
270.
270. So if theta is between 270 degrees and 360 degrees, which quadrant will it have to terminate in?
Oh.
Somewhere over here in quadrant 4. I don't know where, but somewhere in quadrant 4. I'll just put it right there. So all of that in blue is theta. But when we draw our right triangle, it's always from the terminal side to the x-axis. So it's always terminal side to the x-axis. And if this angle is theta, your angle for your reference angle for theta is always going to be the angle that's between the terminal side and the x-axis. So terminal side and x-axis will be where the reference angle will be. Now, they told us that the sine is negative 5/13. So using SOHCAHTOA, sine is opposite over hypotenuse. So the side opposite of our reference angle is 5. The hypotenuse is 13. One of those is negative. Which one is negative? The opposite side or the hypotenuse? Yeah, notice this is below 0, so this one needs to be negative 5. Your hypotenuse is always positive. Okay, and we don't have to do Pythagorean theorem if you know your Pythagorean triples. And what's that missing side? 13 is the biggest side, so I see a number smaller than 13.
8.
12. This is a 5, 12, 13 triple.
Ooh.
So would that adjacent side be positive 12 or negative 12? Positive 12 because it's on the right of 0. Now that we have all those, now we can find the sine, cosine, tangent, and the 3 reciprocal. And they gave us the sine was negative 5 over 13. So what's the cosecant?
Negative 13 over 5.
13 over negative 5. Cosine would be adjacent over hypotenuse. So what would the cosine be? 12 over 13. So what would the secant be? 13 over 12. Tangent would be opposite over adjacent, so what would the tangent be? Negative 5 over 12, so the cotangent would be 12 over negative 5. Okay, one final problem. Last one. This time they tell us that theta is between 180 degrees and 360 degrees. Now that gives us a problem. Because how many quadrants are between 180 degrees and 360 degrees? 2. So it could terminate in quadrant 3, or it could terminate in quadrant 4. Now I have to figure out which triangle is it going to be. And when you draw your right triangle, it's always terminal side to the x-axis, terminal side to the x-axis. And your reference angle is always the angle that's between the terminal side and the x-axis. So these are the two reference angles that it could be. So we have to figure out which one is it going to be.
2 cases.
No, it's not 2 cases, it's only going to be one thing. And if they gave me secant, what is the reciprocal for secant? Cosine. So what would the cosine of theta be? Negative 1/2. means the adjacent side is -1, and the hypotenuse is 2. So one of those triangles is wrong. Which one is wrong?
Quadrant 4.
The one in quadrant 4. Because if this side is on the right side of 0, should that be -1? No. Now we need to find that missing side. We have to do Pythagorean theorem because it's not a Pythagorean triple. So a squared plus b squared equals c squared. So this would be -1 squared plus b squared equals 2 squared. So that would be 1 plus b squared equals 4. And when I subtract 1 to both sides, that gives me that b squared is equal to 3. Take the square root. And b technically could be plus or minus the square root of 3. So you'll have to be careful when you label this side length. Should this be positive square root of 3 or negative square root of 3?
Negative.
It's below the x-axis, so this should be negative square root of 3. Now we can find our 6 trig values, so we need to find the sine of theta, cosine of theta, tangent of theta, and the reciprocal. So secant, secant, and cotangent. And they gave us the secant. What was the secant? -2. So the cosine was?
-1 over
-1 over 2. The adjacent side is negative. And for the sine, how do you find sine? Opposite over hypotenuse, so what would the sine be?
Negative square root of 3 over 2.
Negative square root of 3 over 2. So the cosecant, if I invert that fraction, would be 2 over negative square root of 3. Can I leave my answer like that? No, rationalize that. So multiply both numerator and denominator by the square root of 3. So this is 2 square root of 3 over -3. And the last one is tangent. How do you find tangent? Opposite over adjacent, so this would be negative square root of 3 over -1, which is equal to square root of 3. So that cotangent would be 1 over square root of 3. Multiply both the numerator and denominator by the square root of 3. And that gives us square root of 3 over 3. Now your assignment, make sure you show work to get credit. You'll probably need notebook paper to have enough space to show all of your work.